We are taught from childhood that water is an infinite renewable cycle of evaporation and rain. We look at flowing rivers and naturally assume our civilization is safe. But we are blind to the truth. The modern world is not surviving on recent rain, it is surviving on fossil water. These are vast, ancient oceans trapped in solid stone buried miles beneath our feet. These invisible reservoirs contain water that fell during very different climates, including the last ice age. They are the silent dictators of human history, and the primary reason megacities can even exist in the desert today. But we are now mining this prehistoric water faster than geology can replace it, and our global bank account is nearly empty. In this video, we are diving into the invisible river, from the prehistoric aquifers below to the hidden collapse of the Mayan Empire to the chilling map of the next global migration. To understand the invisible crisis unfolding beneath us, we first have to redefine what groundwater actually is. When we picture a typical water well, we usually imagine a shallow pool of fresh water that quickly refills after a heavy spring rainstorm. But true, deep-time aquifers are something very different. Geological formations like the Ogallala Aquifer stretching across North America or the Nubian Sandstone Aquifer beneath the dry sands of North Africa operate on ancient rules we rarely consider. The Ogallala alone lies beneath 8 different states and quietly supports nearly 1/5 of the wheat, corn, and cattle produced in the United States. It is a buried engine driving global food markets. We have to wrap our minds around the age of this hidden resource. This is not new water. It is a trapped piece of ancient history. Much of this liquid rained down tens of thousands of years ago when massive ice sheets covered continents and woolly mammoths walked across frozen plains. As those ancient glaciers melted, the water seeped slowly down into layers of sandstone. Sandstone is a porous rock, solid stone filled with microscopic holes, allowing it to soak up water exactly like a giant, hard sponge. Over long geological time, climates shifted and tectonic plates moved. The surface changed, but the water stayed locked deep below, sealed away in the dark. Think about the fresh produce sitting in your refrigerator right now. That food exists at all because an industrial drill is pulling up water that first fell as cold rain thousands of years before human history was ever written. This trapped water is now disconnected from our modern weather cycle. It does not evaporate into today's sky, and it does not receive a single drop from passing storms. This simple fact reveals a terrifying vulnerability. Because this underground ocean is isolated from the rain cycle, it does not meaningfully replenish on human timescales. We comfortably treat it like an endless renewable resource, but drawing water from these deep aquifers is just like drilling for oil or mining coal. Once you pull a barrel of oil out of the ground, it is gone forever. Fossil water works in the same unforgiving way. We are not borrowing this clear water to give it back. We are mining it until the rock is dry. We are drinking the ancient past just to survive the present. Travel back to the dense jungles of the ancient Yucatan Peninsula. The Maya built an advanced, sprawling civilization in a challenging tropical environment. They raised towering stone temples, developed complex mathematics and astronomy, and supported populations of millions. But there is a quiet geological glitch in the Yucatan. The entire peninsula has almost zero flowing surface rivers. It is a flat shelf of porous limestone sticking into the ocean. When rain falls, the water disappears almost immediately into the rock instead of forming streams. So how did an empire of millions survive intense tropical heat without a single reliable surface river? Their entire civilization depended on unique geological formations called cenotes. Cenotes are naturally occurring limestone sinkholes, places where the roof of the rock suddenly collapses, opening a vertical shaft that plunges into the darkness below. These openings were their only access points to the hidden river network flowing through the limestone. Imagine the daily tension of that existence. Your family, your city, and your entire culture depend on dropping a bucket into a dark hole every morning, hoping you still hear the splash. The ancient Maya revered cenotes as sacred portals to the underworld, but building an empire on an invisible, unpredictable river is a dangerous gamble. These underground channels are sensitive to shifts in the rock and to changes in sea level. Think about the tap water you use to brush your teeth each morning. In a desert city, that water is not guaranteed by clouds and rain. It is a temporary luxury drawn from a disappearing source. These cities survive because of non-stop industrial pumping of fossil water. Deep wells run hundreds or thousands of feet into the crust, lifting water that has not seen sunlight for thousands of years. The irony is stark. We build water parks, lush golf courses, and vast green fields in the middle of landscapes that were naturally dry for millions of years. A significant share of pumped desert water does not even go to drinking. It is sprayed over fields of water-hungry crops like alfalfa, which are then dried and shipped around the world to feed cattle. A bright green field in a 4-inch rainfall zone is not a miracle. It is a magic trick powered by draining an ancient account. Humanity is now locked in a race. On one side is the push for large-scale desalination, industrial plants that strip salt from seawater to make it drinkable. On the other is simple arithmetic, the rate at which we are emptying underground reservoirs. The volume of water required to keep millions alive in the desert is staggering. Studies show groundwater levels are dropping faster and more widely around the world than experts once expected. We treat the ground as if it were an endless tap, ignoring the simple reality that the stored water is finite. As the invisible ocean beneath us drains, the solid ground begins to respond. This leads to a difficult physical question. What happens to the earth when we rapidly empty an underground water store? Many people picture groundwater as a lake in a cavern, like a hidden pool inside a cave. But that image is wrong. In most aquifers, water sits inside tiny pores in the rock. Because water has weight and cannot be compressed, it helps support the weight of the earth and the structures above it. This brings us to subsidence, the slow sinking of land. When we pump fossil water out with powerful wells, the porous rock dries and loses its internal support. The tiny spaces that once held water collapse, and the grains of rock are pressed tightly together. Think about the foundation of your home or the supermarket where you shop. You assume the ground under these buildings is fixed and solid. If the support water beneath that ground is drained away, the entire structure is suddenly resting on a weakening sponge. The result is that the land surface begins to sink. This is not theory, it is happening now. In California's Central Valley and in coastal cities like Jakarta, the ground has dropped meters in some places over just a few decades due to groundwater extraction. As the land sinks, roads crack, buried pipes snap, and building foundations twist. Repairs cost billions, and some damage cannot be undone. We are literally deforming the surface of the planet to sustain a temporary illusion of abundance. The worst part is that this damage to the rock is permanent. Once porous layers are compacted, the tiny spaces that held water cannot reopen. Even if floods arrive later, the rock can no longer store that water. The underground sponge is crushed. The invisible river is gone for good. Subsidence is only the first visible symptom. The deeper consequence of exhausting fossil water will be reshaping of where humans can live at all. Now shift from geology to geopolitics. A society can weather a financial crash and rebuild its economy. A nation can survive political turmoil and write a new constitution. But no city, no army, and no empire can survive the loss of safe water. There is no synthetic substitute. We have invented replacements for rubber, fuels, and even some kinds of food, but nothing replaces clean, drinkable water. When major fossil aquifers finally run dry, the change will be swift. Scientific studies and global assessments warn that many of the world's most stressed groundwater systems could reach crisis points within this century if current trends continue. When that moment arrives, large regions will become effectively uninhabitable. Imagine the desperation that sets in after only 3 days without water. Now expand that feeling across a city of 10 million, at the moment the pumps draw up nothing but air and mud. This is not a distant science fiction scenario. We can already map where the next water-driven conflicts and refugee waves are most likely to emerge by looking at today's groundwater decline and water stress maps. Water stress simply means that demand for usable water far exceeds the supply in a region. As wells fail and crops die, millions of people will be forced to move. Families will leave ancestral lands and push toward the few regions that still have flowing rivers and stable aquifers. That movement will strain borders, economies, and political systems that already feel fragile. The future borders of our world will not be sketched solely in conference rooms by diplomats. They are already being traced in secret by the falling levels of underground water. We built a vast engineered civilization on top of a quiet geological assumption that the water under our feet would always be there. We thought we had conquered nature. In reality, we were living on borrowed time. It is time to stop staring at the clouds and start paying attention to the stone. We must accept a shift in perspective. Every time you open a tap in a dry city, you are not interacting with today's weather. You are draining a finite, ancient reserve of Ice Age rain. The invisible river beneath us gave us the illusion that growth could continue forever. If our greatest megacities rest on a geological bank account that is steadily approaching zero, we are forced to ask one question. What is the plan for the day the pumps finally pull up nothing but dust? If you want to see how the hidden geology of a dead supercontinent secretly dictated where we built our modern cities, click the video on screen to explore the ghost map of Pangaea. See you in the Curiosity Gap.